Good day, I'm Dr. T. Welcome to my kitchen table. Today I'm doing a little bit of chemistry questions and jumping into this one. So this is a limiting reagent try not to bump the camera. This is a limiting reagent problem with a percent yield. So this is kind of the whole kit and caboodle when it comes to running a lot of your stoichiometry questions. And in this case, we're sticking with solids, which does make life easier. Okay, so if you react 3.855 grams silver 1 nitrate with 2.98 grams sodium carbonate, yielding 1.225 grams of silver 1 carbonate, what is your percent yield? Hint, the unbalanced chemical equation is AgNO3 plus Na2CO3 yields Ag2CO3 and NaNO3. Okay, so we got a lot of stuff going on with this one. So first off, let's do some formula weights. By the way, interesting note, there's a bit of a controversy whether or not I should be calling that silver 1 carbonate or just silver, because you don't usually get a silver 2 or a silver 3. I think there is like one weird example of one. Okay, so first things first, I am getting a periodic table, and I'm going to start grabbing the formula units for these guys. So I'm going to start with this guy. I'm going to need this one. I'm going to need this one. I don't need him, but I will need him because these are the ones I have grams for. Okay, so silver. Silver is going to be 107.87. Plus nitrogen is going to be 1401 plus 16.00 for the oxygen, and there's 3 oxygens. So this is going to be the AgNO3. Okay, so that, I'm going to type that mess in my calculator, 107.87 plus 14.01 0.01 plus 16 times 3. Okay, that is going to be 169.88 grams per mole. Okay, next one I'm going to do is going to be Na2CO3, good old washing soda used to make soap. So sodium, that's going to be what, 22.99? And you will find the numbers do vary a little bit. Some periodic tables are a little bit out of date. Other ones will actually have ranges because it turns out that depending on where on Earth you are, that does matter as to what values you get for some chemicals. If you need to, you just pick a number in the middle of the range. Okay, so I have 2 sodiums. Plus carbon, that's going to be 12.01. Yes. Use some of these enough, you get them memorized. Plus 16.00 times 3. Okay, so calculator time. I ain't doing that in my head. With this one, make sure your calculator does do order of operations before you type this in. If it doesn't, you can still do it. You just have to be careful. You have to do the forced order of operations yourself. Okay, 105.99 grams per mole. And the last one I want is going to be a really heavy one, Ag2CO3. Okay, so this is going to be 107.87. These are all grams per moles. I'm just putting the units on the very end. That's times 2 plus 12.01 plus 16.00 times 3. That's going to give me 107.87 plus 12.01 plus 16 times 3. That's going to be 167.88. Now, test for those at home. What did I do wrong, and how do I know I did it wrong? Here's how I know I did it wrong. Notice this number. This is for a guy that has 2 silvers. Silvers are heavy. Now, compare that to this number. Well, technically, you can barely see it there. But look at this number. This number should not be lower than that number. He only has 1 silver. This should be much bigger. So I know that this number is wrong. I've done something wrong. And looking back, I forgot my 2. So I'm going to do this again. But this time, I'm going to times it by 2. Okay. Hopefully I did it right this time. 275.75 grams per mole. Okay, so that was needed. Next thing I need to do is I need to balance that. This is an unbalanced equation. So I'm going to say, okay, AgNO3, I don't have room there, that's why I'm rewriting it, plus Na2CO3 yields Ag2CO3 plus NaNO3. When I'm doing this, I can take these polyatomic ions like the carbonates and the nitrates, and I can just treat them like one thing, which is going to make my life easier. Okay, so right off the bat, the nitrates are balanced, but the silvers aren't. So I'm going to put a 2 here. That unbalances the nitrates, so that needs to be balanced. Okay, so now the silvers are balanced, now the nitrates are balanced, the sodiums are not, so I need to put a 2 here. No, I don't. I've got a 2 there. So, hey, what's up with these carbonates? I can't put a 2 there. But no, now the sodiums are balanced because there is a 2 there, and there's now 2 in NaNO3. That does not look like an N, does it? Yeah, it looks even worse. Okay, so I've got my balanced chemical equation. Now, this is a theoretical yield question with a limiting reagent. So that means I'm actually doing 2 theoretical yields. Let's see if I just knock that thing out of view. I need every ounce of this paper. Okay, so I'm going to be doing 2 different theoretical yield calculations. I'm going to run them in parallel. Okay, so the first one is going to be my AgNO3 one. And this is assuming that AgNO3 is the limiting reagent. And the next one is going to be the Na2CO3. I assume that's the limiting reagent. So I'm going to start out with what I know, and that's going to be my 3.855 grams, not in, AgNO3. Wow, that looks hideous, my bad. And this one's going to be 2.98 grams Na2CO3, otherwise known as washing soda. I think I already said that. Okay, so next up, I'm going to convert those into moles because I can't do anything with grams. I'm going to have to go moles. So I've got the formula weight, that's grams per mole, so that means the moles are going to go on top. Grams are going to go on bottom. So 169.88 grams, and technically I need to say AgNO3, AgNO3. This gets old, but you know, you want to do it. That allows you to track down oopses. Like that. That's not AgNO3. Na2CO3. Okay. And this is going to be 105.99 grams Na2CO3. Okay, so now I'm looking at my mole ratio. So I'm not going to jump into it because I've canceled out grams in both cases. I'm left with moles. So I want to do my mole to mole ratio, and that's coming from this equation. So what I want on top, and that's going to be my 1 Ag2CO3. It's a 1 because there's nothing in front of there. It's going to be the same for both of these. And then on bottom, it's going to be a 2 here. And down here, that's just going to be a 1. And at this point, I'm going back to grams. I don't actually have to go back to grams at this point. I can do moles here, but I'm just going to go back to grams because I'm going to need it anyways. It's not that much work. So this would be 275.75 if I was doing this by hand, instead of using a calculator. You better believe I'll be taking every shortcut. But I have a calculator, so I don't need to. And then this is 1 mole Ag2CO3. I probably should have put the word mole there, but I usually don't. Either way is fine. Let's see. It's only 5, not 3. 7.5 grams. Ah! Yeah, no, that was right. That was right. So now I get to cancel that out. I get to cancel the moles out. Because those have already canceled. And yay, I'm good. So at this point, calculating time. So, .855 divided by 169.88 divided by 2 times 275.75 gives me 3.12876 grams. I know I don't have that many sig figs. Ag2CO3. And then the other one is going to give me 2.98 divided by 105.99 times 1 divided by 1 times 275.75. This one gives me 7.752948 grams Ag2CO3. Okay, so when looking at this right off the bat, this is lower than this one. This is a limiting reagent problem, so I know that one of these will be used up, one of them will not be. This one is used up. This is my limiting reagent. This one is not. That is my excess. Now, I could go back and calculate how much of this was used up. That is a valid thing to do. That's annoying, but I could totally do it. But I'm not going to do that because that's not what the question asks. It wants percent yield. So percent yield is going to be actual yield over theoretical yield times 100%. Now, this is my actual yield. So I will take 1.225 grams Ag2CO3, because those are the same thing, divided by my theoretical yield, which is now that. And actually, I need to do sig figs on him, because he's not quite done yet. I've got 4 sig figs, 5. That's an exact number. I don't have to worry about those. Once you come from here, those are exact. Those are a counting number. And that's a 5. So I've got 4 sig figs. So 1, 2, 3, 4. That's the one. So this is actually 3.129 grams Ag2CO3. But that's not what I'm going to write down. I'm actually going to keep this number up here. 3.128726 grams Ag2CO3. You're like, but why? Simple. When I rounded this, I changed this number. I made this number just a little bit bigger. And because I made that number just a little bit bigger, I'm going to add error into my math. So while this is my theoretical yield, not that one, I'm going to use this number down here, so that way all of my rounding is done at the very, very end, if at all possible, or it is rounded well into those numbers I don't know that are real. Okay, so I should not have done that because I still need to times by 100%, and now I can get my number. Okay, so now this time I can do 1.225 divided by 3.12876 times 100. This gives me a percent yield of 39.1533%. And now I'm going to round. I know that this number is 4 significant figures. I know that this number is 1, 2, 3, 4. Oh, look, they're both 4 significant figures. Therefore, 1, 2, 3, 4, that's where I'm going to round. So now I get 39.15%. And that really is my final answer. So yeah, this one, limiting reagent problems are always one of those, it's a little bit creepy. It's like, there's so much to do, but it's like cutting down a forest. I don't know why you're cutting down a forest, but it's like cutting down a forest. Take it one tree at a time. Just break them apart, tackle them one part at a time, and they're not bad. They're annoying, they're just not that bad. So with that said, have a wonderful day, and I will see you in later videos.